In this video series, we're going to talk about rational functions. To introduce these and to understand better what they are, let's look at an example. Suppose you get paid a salary of $56,000, and we're going to assume this is a yearly salary. You would like to understand your hourly pay better to be able to compare it to a person earning an hourly wage instead of a salary. So let's just suppose that a person works the typical 40-hour work week. Okay, well, this is an annual pay, so the first thing we would need to do is kind of figure out, well, how many hours would that person work overall in a year? So let's do that. We know that there are 40 hours in a week, and or typically this person's working right now, we're assuming 40 hours per week, and let's just assume this is times 52 weeks in a year. So that means if this person worked 40 hours for all 52 weeks, that person would have worked 2,080 hours. So this would correspond to, so we'll call this weekly hours. And so that means that the person would have worked, I'll put it off to the side, 2,080 hours in that whole year. Okay, well, their annual salary is $56,000, so to figure out what their hourly pay is, we have to figure out, okay, if we took $56,000 and divided it by 2,080 hours, we could figure out dollars per hour. So that would be 56,000 divided by 2,080 hours, which would be about $26.92 per hour. So not bad, pretty good wage. Well, what happens is this starts to increase. So most people who are salaried work a lot more than that. So 50 hours. Well, we would need to figure out the total hours in that year to get it on the level of this salary. The salary is based on a year, so we have to figure out how many hours there are in a year. So 50 hours per week times 52 weeks, this person will have worked 2,600 hours in that year, and take 56,000 divided by that, we would figure out that 56,000 divided by 2,600 hours would come out to about $21.54. So $21.54 per hour. And as you can see, that increase in the number of hours has actually decreased the pay. So if you look at the rate of change for the additional 10 hours, it looks like $5 and, let's see, I'm trying to figure out the difference here, 38 cents if I've done my calculations correctly. So that means this person has lost $5.38 per hour. Now, let's just say this person works 60 hours. Well, you can start to imagine what we're kind of doing here. We're taking the 56,000 and we're dividing it by the total number of hours in the year. So 60 hours a week times 52 weeks would come out to 3,120 hours, which would translate into 56,000 divided by 3,120, and that would come out to $17.95 per hour. Okay, and again, you can see that drop is still pretty significant, but $21.54, $17.95 minus $21.54, that'll give us a negative, tell us how much the drop is. The drop was by only $3.59. So we notice that the rate of change is not constant. So that means, what does that tell us? That means this is not a linear function. That's what we can definitely deduce. Because the rate of change is not linear, or is not constant, well, it can't be a linear function. Well, the second question we would have, are the changes in the rate of change is constant? Well, to look at the change in the rate of change, we need a couple more values in this table, and we can certainly do that. But if you do that for 70 hours, you'll notice that the change in the rate of change is not constant. So that's not going to be a quadratic. And if you look at the ratios of 2154 to 2692, you get a decay factor of 0.8. If you do 1795 divided by 2154, well, what happens to that decay factor? It's not constant. That decay factor is actually getting bigger. It's getting closer to 1. So we also don't have an exponential function. Well, let's keep track of what we did. So let's say that we have hourly wage. So let's just say that column was W, and this was the number of hours. So what did we do?